Hello and welcome to this lesson. In this lesson, we are looking at indices, also known as exponents or powers. By the end of this lesson, you should be able to understand indices, 2. State and use the laws of indices, 3. Solve simple problems involving indices. Now, what are indices? Indices or exponents show how many times a number is multiplied by itself. For example, if you have 2 exponent 3, it means you are multiplying 2 by itself 3 times. So you have 2 by 2 by 2, and that will give you 8. Some key terms you are supposed to take note of. The first one is base. The base is a number being multiplied, and index or exponent. It is the number of times the base is multiplied. For example, in 5 exponent 3, 5 is the base and 3 is the index or the exponent. This means that you are multiplying the base, which is 5, by itself 3 times. And if you multiply 5 by 5, you get 25. If you multiply the 25 by 5, you get 125. Index notation. If you have 3 by 3 in index notation or in indices form, you have 3 exponent 2. 5 by 5 by 5 will give you 5 exponent 3. 10 by 10 by 10 by 10 will give you 10 exponent 4. The laws of indices. The first law is multiplication of indices. If you have a number exponent another number by a number exponent another number, here the base should be the same. If the base are the same and they are multiplying, you write one base and you add the exponent. So a exponent m multiplying a exponent n will give you a exponent m plus n. For example, if you have 2 exponent 3 multiplying 2 exponent 2, this will be equal to 2 exponent 3 plus 2, which will give you 5. That will give us 2 exponent 5, and 2 exponent 5 is 32. Now you ask, why did we get this 32? 2 exponent 5 means we are multiplying 2 by itself 5 times. So 2 by 2 by 2 by 2 by 2 5 times. 2 by 2 is 4. 4 by 2 is 8. 8 by 2 is 16. 16 by 2 is 32. This means that 2 exponent 5 is equal to 32. The second law of indices, which is division of indices. If you have a number, 2 numbers with the same base dividing, you write one base and you subtract the indexes or the exponent, which means a, you write the base as a, then you write m minus n. For example, if you have 5 exponent 4 dividing 5 exponent 2, because the base are the same, we write one base 5 and we subtract the exponent 4 minus 2. 4 minus 2 will give us 2, and that will be 5 exponent 2. 5 exponent 2 will give you 25. Why is it 25? Because 5 exponent 2 means 5 by 5, and 5 by 5 will give you 25. The third law of indices, the power of a pair. Now, if you have an indices or a number raised to the power another number, and the whole thing is exponents a certain number, what you do is that you write the base as 1 and you multiply the exponents. So here the base is a, and I'll multiply m by n. For example, if you have 3 exponent 2 all exponent 3, this will give you 3 exponent 6. Why 6? Because we multiplied 2 by 3 to give us 6. So 3 exponent 6 will give you 729. If you multiply 3 by itself 6 times, you get 729. The fourth law, which is the zero index. Whenever a number reaches a power of 0 or any number exponent 0, the answer is 1. I repeat, any number exponent 0 will give you 1. But remember that the number shouldn't be 0. For example, 7 exponent 0 is equal to 1. 100 exponent 0 is equal to 1. Why is it 1? Because when a number is exponent 0, it means the number is dividing itself. And if a number divides itself, the answer is 1. Negative indices. If you have a exponent negative n, it will give you 1 over a exponent n. This means that a exponent negative n will be equal to 1 over a. Now remove the negative and you have n. For example, 2 exponent negative 3 will be equal to 1 over 2 exponent 3. Here, I'm just removing the negative from the 3 and representing it as 1 over 2 exponent 3. Then if you simplify, 1 will still be written as 1 over 2 exponent 3, which will give you 8. And why is 2 exponent 3 8? It means you are multiplying 2 by itself 3 times to get 8. Now, I want you to follow the laws that we discussed and solve the following problems. Example 1. Simplify 4 exponent 3 by 4 exponent 2. Example 2. Evaluate 2 exponent 2 all exponent 3. Example 3. Simplify 9 exponent 4 divided by 9 exponent 2. I want you to try this on your own. 5 exponent 0. 6 exponent 2 by 6 exponent 3. 10 exponent 5 divided by 10 exponent 3. 4 exponent 2 all exponent 2. 3 exponent negative 2. What did we learn today? The summary of our lesson. We've learned that indices make repeated multiplication simpler. I believe that you now know and can apply the laws of indices. And I want you to practice regularly to build your confidence. Take your textbook, take your exams papers, your class test sheets, and look for questions like this and solve. And as you are solving, you are building confidence so that you can be able to solve difficult questions than this. If you have any questions, I want you to ask. Feel free and ask your questions, and I'll respond to them. You can also follow me on my YouTube channel at Sir Newton Obodo.